Greetings. So today we'll be looking at the mechanism, crank mechanism. Now, we spoke about the theoretical aspect of the crank mechanism, but now I'll be demonstrating the construction of the crank mechanism. What we want to do first, we want to assess the instructions, see what they're saying, what they're asking us. There is example A here, which is plotting the locus of point B behind the pivoting point C, and there is example B, which is plotting the locus of point P, which is in front of the revolving circle. So this circle here, this crank here rotates in this circular motion, and this crank here rotates in this circular motion. You have different types of crank, but these are the types we'll be looking at for this level of our education. Now, what we do with this is we read first. So it says here, the drawing shows a mechanism in which OA revolves in a clockwise direction about O. So OA, which is this line here, rotates in a clockwise direction around this center, which is O. AB is constrained to slide through the pivot block C. So AB is constrained, meaning it's fixed at C, and it slides through C backwards and forwards depending on where it is located here. Right? So when it's at 6, it will push it backward to 6 at this point here. So all these lines are representing its motion through a revolution. Plot the locus of B for one revolution of OA. So when OA spins through a complete revolution, where will B at each point? So at point 1 at 1 here, B would be here, where 1 is. At 2, B would be at 2. At 3, B at 3, 4, 5, 6, and so on and so forth. So it is this point which is fixed here. While rotating, we'll push and pull point B here, all the way out to all the way in. The center of block C is located by two dimensions, which is 120 millimeters given from this center to here, so you offset from this to here 120, and 20 millimeters from here to here. So between this center line and here is 120. Notice this arrow and this arrow points to, and you didn't put the 20 here because they didn't want to confuse you with all the lines, so they put the arrows on the outside and 20. So you offset from this 120 and from this one 120. It says draw the initial position of the mechanism. So you're going to draw OA and B to C, which is the darker lines first. You're going to draw the circle. It says draw the initial positions of the mechanism and divide the circle through A into 12 equal parts. So you draw a circle, divide it into 12 equal parts. It says that AO is 50, so that tells us what the radius of the circle is. Then the diameter is 100. Says draw a light outline of the mechanism for each of the 12 positions of AO. Join all the plotted points to B to obtain the required locus. So you're gonna draw a line from A to B through A through C to B through all these points. And it says here that AB from A to B is 180. So when it's at 2, you measure 180 going all the way through C to B, and wherever 180 stops is where your point is. So let's attempt this. Here's a completed drawing. So let me show you how you get it. The first thing you want to do is to draw your center lines. Line. You want to draw a circle, which is 50 in radius, 50. Enter. If you're using diameter circle, it would be diameter, right? So you divide this into 12. Connect your points. To re-enter the command, I just press enter and enter again. So enter off, enter on. Alright, that's it. Next thing to do is to locate point B. Not point B, point, what what is it? Point C, locate point C. So locate point C. Point C is offset 120. You can type offset or you can um, decide to click the icon. So offset 120. Enter from there to there. Now offset 20. From there to there. This becomes point C. Alright, excellent. So we can change this to center line. Good. So now that we find point C, we can radiate all our points through point C from AO all the way to 1, 2, 3 to 11. So we're going to do that now. So radiating the lines from AO to C. Alright. Then see, let's see properties, length 158. So the length is 158 and I want 120. May need a calculator. So let me get the calculator here. Alright. So we want to extend this line now to be 180. So we find what the measurement is, quick properties. Its length is 158. So 158.5 minus 180. So we find out what we need to add to it. So 180 minus 155. What was it again? 155? Quick properties. 158.5, right? Minus 158.5 equals 21.5. So we need to add 21.5 to this. So we turn off ortho so we can get it to go in an angle. So we add, so the length of the line is 158.2, so we add 20, 158, we add 21.8, 21.8, enter, and it's now 180. Good. So the first line has been drawn, and this first line is representative of this crank. So we're going to brighten it now. To object line. Not all of it is object line, so we're going to rejoin this one. Alright, that's where we have the crank. So this is the crank in its original position as it asks us to do. It says to draw the initial position of the mechanism. So this is the initial position with the dark lines and the circle. Now we need to find all the other points. So we have point B now, so we need to find point 1 all the way around to point 11. Point B is basically point 0 here. So we need to point 1. Where is it? Points at point 1, point 2, point 3. Because remember, this is rotating. This point here, AO, is rotating through 1, through 2, through 3. And it is this point that is marked out through all of these points. So we're going to do the same process like this for all of them. Connect to C, then find out what we need to add to it to make 180. And then when you get all the lines, you draw a complete line around it. So let's go. 9, 9 from point through to C. Ensure that it touches the center point properly, because at times it fails to. Right, so it's there. Quick properties, it's 169.4. So 180 minus 169.4 equal 180 minus 169.4 equals 10.6. So you need 10.6 to add to this one. So boom, there, 10.6, 10.6, enter. And you get that point, right? So you have point 1, point B, point 1. So the same thing you do for all of them coming around now. So from this one to exactly in the point, right? Then find what length of that is. It is properties. It is 171.2. 180 minus 171.2 is equal to 8.8. So we add 8.8 to that one. 8.8, 8.8. Enter. We got that point. So we continue doing the same thing all the way around. Connect it to C. If you were using a pencil and ruler, it would be much easier, I promise you. Because all you need to do is to measure from this point through C and measure where 180 stops. But because it's AutoCAD, we have to find another way to get it done. Properties 163.4. Alright, so 163.4, the calculator. 180 minus 163.4 equal to 16.6. So we're going to add 16.6 to that one. 16.6. Enter. Right, for the next one now, to center C. Alright, what is measurement of this one? It is quick properties. 146.9. So 180 minus 146.9 gives you 33.1. Alright, so you need to add 33.1. So add 33.1, going in this direction, 33.1, enter. And you notice when you line up with the line, when you have your polar tracking on and you line up with any of these lines, it turns green. So from this point, as long as you line up with any of the lines, it gives you a signal that you're there. See? It turns green in some fashion. For example, there, 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 and there. I'll show you the next one. So we're doing point, this is 0.6, 0.5 now. So we're doing 0.5 from there, connect to C. And if you continue on this part, you will see. Connect there. And this is it. See? So it gives you a kind of indication that you are in line with this line here. right there. So it says extension. See the word extension? So you're extending at 166 degrees that line that you just drew. So you try to find the line that is the one that is in line, right? This is also an extension of a line, or extension of a line, right? So this says extension here, so that's what you want to find, the extension point for this line. So what we needed was, oh, we didn't take the measurement here yet. So the measurement of this one is quick properties 123.7. So 180 minus 123.7 equals 56.3. So we need to add 56.3. So 56.3, 56.3. Enter. We get that one. How about this one now? Right there. To C. Alright, so this one is that one, and this one is properties 97.8. So 180 minus 27.8 is equal to 152.2. 152.2. So we need to add 152.2 to this one here. It comes along this point and they meet exactly same place. Alright. So this one will be extending Alright, this one is a bit tedious because it's almost in line with this one. 5 and 4 is almost in line and they meet at the same place. So let's see if I can get this done by doing it this way. Oh no. See if we can get it done by extending like this. So I need what? 156? I don't even remember what I needed anymore. Man, this is getting crazy. Alright. So for this one, measurement was quick properties 97.8. So 180 minus 97.8 equals 82. So I need 82.2. 82.2 is what I needed. Extend this. Eighty 2.2. Enter. No, sir. Mark. So see properties 180. And then this 180. Let's see if I can move it down. skips from there. Alright, so boy. This is not easy. Not an easy road, yeah. Not an easy road. Alright, what I'll do, I'll leave this one out for now. Because it's giving a little bit of challenge because it's too close to the other one. Too close to the other one. Move from there. Let's see if it goes there now. Oh, sir. Alright, I'll come down just a little bit more. Pass it. Ah, boy. Zero. He's so small that it counted as zero. Alright, so this is now go through the middle. So I'm gonna leave this one out for now. Leave this one out. It's too close. So I'm gonna do the 5, leave 4 out and the 3 and see if I can get somewhere. So from 3 to the center line and then extend 3 by just these quick properties 76.9. 180 minus 76.9 equals 103.1. So extend by 103.1. 3 3 3.1. 103.1. Enter. I still jump out at the center, but yeah, let's go work with it for now. Do the same thing for 4. If you jump out, you jump out. We can't manage. It's rough. Alright. If you can find an easier way to do it, please. Beg you. Find an easier way to get it done that way. Pass through the center. 180. Enter. Alright. Fully pass through the center, but something better than nothing. Alright, so boom. 180. 180. Enter. 180. Enter. 180. Enter. Alright, so 180 to the center. 180. Enter. 180. Enter. If you want to do it like this, you can. Because it's difficult to find to get it done accurately um, in AutoCAD. So 180, enter. When you zoom out and looking at it, you can tell say the line them not really meet in the center because this is 0 micromillimeters basically. So from here to here is 0, see? So you never recognize as a millimeter. So the accuracy is off, but it is impossible to tell because you have to zoom in to see it. So it's basically the same thing, and it's all the lines are 180 if I check it. Properties 180. With properties 180. So all the lines are 180. It's just that the accuracy is micromillimeters of precision. Here, if you look at this, you will see the same thing is happening. So it's rather impossible to get it done with 100% accuracy. So this is how I went about doing it. Just to save time and patience. SPL, enter. Connect all the points now. All the edges that extend to 180. Just zoom in to find the others. Boom. And this one here. This one here. This one here. This one here. And there you go. That is the shape that we get when we plot them. See? And it's similar to this one. What you can do is replot it from the center. So SPL, enter, and replot it from point B. Start there, go around, and come back directly to B afterwards. And that, there you go. Object line, and that's you. Now you can finish doing your labeling and your locus, label your locus, label this 20 here, label this 120, and label this arrow, and all your lettering and numerals, and you'll be done. Alright, remember, because these drawings were made for manual drawing, so you have to use ruler and pencil and compass, they were constructed with that in mind. Now AutoCAD is a software that makes geometric drawings redundant, but because these drawings are still a part of your syllabus, we have to be ingenious and creative to find a way to teach you how to do these drawings using AutoCAD just the same. So everything won't work out the same way, but we have to be creative in finding solutions to get it as close as possible to what it is, right? Alright, thanks for your time.